Okay, this is part 2. We're getting a little more difficult. We're going to start off with this set. Now, if you haven't watched part 1, we start off part 1 with a basic review of how to find out what the charges of ions are and about polyatomic ions, and so it's important to watch that part. You got to have your good periodic table out and your green sheet out in order to do any of this, and so it's important to watch part 1 if you haven't watched it already. So let's do these 4 right here. Pause the video. We have these 4 to work on, and when you get done with them, start the video again and we'll go over them together. Okay, the first one is aluminum nitrate. What we have to do here is figure out what these things look like as ions. Aluminum is always a +3 charged ion. It lives in that family on the periodic table. They form +3 ions, so we always know that one. In nitrate is one of those things on the green sheet. It's a polyatomic ion. It's a -1 charged polyatomic ion. There's 1 nitrogen and 3 oxygens. Altogether there's -1 for a charge. So if aluminum's +3 and the nitrates are -1, I want to get together a gang of 3 nitrates. Now this is something we haven't really seen yet, so this is a little more difficult, but not bad at all. Nitrates, all 3 of them together would be -3, and that's what we need to do in order to make an ionic compound that's got no charge. So we have got 1 aluminum and 3 nitrates. Now we're going to run into a little issue here. We want 1 aluminum, and we want 3 of this whole nitrate thing. Now, if I just put a 3 there, it kind of looks like I want 33 oxygens. And that's not what I want. I want 3 of the whole nitrate chunk. So we kind of borrow a little thing from math class here. We're going to use parentheses in the distributive property to say we want 3 of that whole nitrate chunk. And so now we've got an ionic compound with a +3 ion from the aluminum and 3 -1 nitrates. And so overall we've got no charge. Now when we go to the next one, we'll see what happens here. Nickel 3 sulfite. Nickel 3 sulfite. All right, well, nickel. That's the symbol for nickel, Ni, but what's the charge on a nickel? There isn't 1 charge. There's actually several charges. So unless someone was nice enough to tell you what the charge was by using a Roman numeral, you wouldn't have any idea. But that 3 right there, the Roman numeral 3, tells us this is nickel with a +3 charge. And now this is being paired with sulfite. Sulfite is a polyatomic ion. It's on your green sheet. I can tell it's a polyatomic ion because if they end in ate or ite, those things are got to be off the green sheet because all of the ions that are just monoatomic that come from the periodic table all end in IDE, ide. Since these guys are ending in weird things, well, I know that they might be on the periodic table. So sulfite is SO3 with a -2 charge. And so when I look at these and I compare them, I got nickel with a +3 and sulfite with a -2. This is not going to be easy. If I take another sulfite, together they would be -4, which means I'm going to have to take another nickel. Together these 2 nickels are +6. So I'm going to take a third sulfite, SO3, with -2 charge. Altogether, that group of sulfites is going to have a -6 charge, which will balance out nicely with my nickels. So I've got one that's going to look like this. Nickel, I want 2 of those guys. And if they pair with 3 sulfites, now I want 3 of the whole sulfites again, so it's another one where we need parentheses. SO3, and I want 3 of those things. Now again, we leave the charges off when we write our answer because when we get these nickels and these sulfites together, they balance each other's charge out. There is no charge. Moving on to this next one here, ammonium hydroxide. All right, this is a difficult one because it contains 2 polyatomic ions. We have not talked about this ammonium guy yet. But if you look on your green sheet of polyatomic ions, in the upper left-hand corner, you're going to find that there are 2 polyatomic ions that are positive, ammonium and hydronium. All the rest of the ones on there are anions. They're negative. But the ammonium ion is a polyatomic cation, a polyatomic positively charged ion. We won't work with hydronium until we talk about acids and bases in chemistry too. But this ammonium ion is one that you got to watch out for. Ammonium, you would probably look on the periodic table for a long time before you found ammonium. It's not there. It's a polyatomic ion on your green sheet. And then hydroxide. This one's a little tricky because it ends in "ide." The "ide" ending makes you think it's got to be on the periodic table because all the ones that end in "ide" come from the periodic table. But hydroxide is one of the polyatomic ions that ends in "ide". Cyanide is another one. And so hydroxide is also on your green sheet. It is OH with a -1 charge. So this one, when we look at it, isn't difficult once we get the ions figured out. We have a +1 ion and a -1 ion. So the compound looks like this, NH4OH. But what makes this one difficult is that we've got a polyatomic cation, which is ammonium, and that's the only time we'll ever see a polyatomic cation is with ammonium. And we've got this polyatomic anion that ends in IDE. So none of this stuff is on your periodic table. That makes this one a little bit tricky. Other than that, writing it's a snap. And for our very last one, we have to write a name. So what we're going to do is we're going to look and write the name of the cation first. Na is sodium, we know that. Then we ask ourselves the all-important question, do we need a Roman numeral? Does sodium form an ion with several, does sodium have several different kinds of ions? And it doesn't. Sodium is an alkali metal. It's always +1, no Roman numeral necessary. So then we look at the second part here. That looks like, it's got many atoms in it. It is polyatomic. And so that one we'll find on our green sheet is hydrogen carbonate. So the name for this guy is sodium hydrogen carbonate. Done with that one. All right, let's try one more set, and you should be good to go. All right, this last set is all names to formulas, and I wrote this one specifically to illustrate a point. There's some trickiness with the namings and the way you pronounce things and write things that we got to be careful of. So take a minute, pause the video, do these 4, and then we'll do them together. Okay, starting with sodium nitrate. Sodium, it's a +1 charged ion, always. Nitrate is one of those guys off of your green sheet. It ends in 8, which is a good clue that it's a green sheet guy. So sodium is +1, nitrate's -1. We have NaNO3. Easy enough. Now sodium nitrite. Again, we're dealing with that positive sodium ion, but nitrite. How does the "ite" ending different from the 8 ending? Well, when we look on our green sheet of polyatomic ions, we've got NO2 with a -1 charge. So nitrite has got one less oxygen than nitrate, but it's still got the same charge. So that looks like NaNO2. One positive 1 ion goes with one -1 ion in order to make that compound. Now when we go on to the next one, we have sodium. Again, sodium is a +1 ion. And we're doing nitride now. Nitride is well, what would it be? It's just nitrogen. It ends in "ide." That's a tip-off that it's probably from the periodic table. And so we have to look and see what kind of ions does nitrogen form. It turns out nitrogen is in a family with phosphorus. Those guys form -3 charged ions. And so sodium and nitride, we're going to need 3 sodiums to pair up, form a group, so that they've got a +3 charge to go with 1 nitride in order to balance this thing out. So sodium nitride is going to look like that. So this is a point that I'm trying to make here. When you write formulas, when you write names, and when you speak about these things, it's very important that you are careful as to what you write or say. Because nitrate, nitrite, and nitride all sound very similar. But you can see here that it makes a big difference in how the formula turns out. The first one is sodium nitrate, then we have sodium nitrite and sodium nitride. That little bit of change at the end of the name makes a big change in the formula, so you have to be careful. Now the last one we're going to do is a little odd in the respect, well, let's just do it and see. Ammonium carbonate. Ammonium is that weird polyatomic cation that we know about, we did in the last set here. NH4 with a positive 1 charge, and carbonate is also a polyatomic ion. It ends in 8. That's a good tip that it's polyatomic. It's got a -2 charge. So I'll want to take 2 ammoniums together. They would form a +2 charge, and we will have a compound that looks like this. Now the reason this is a little odd is because this is the only time when you'll have to use parentheses for the cation, for the first thing. We want 2 of the ammonium chunk and 1 carbonate in order to make that neutral ionic compound. If you're still having questions about any of this, and you've watched both parts of this video, it's important that you get in and get help with this right away.